Welcome to lecture 37, which is on the different components of the drone and their functions. So, in this lecture, I am going to cover what are the different components required uh, and what is their utility. So, this is very important in order to understand the geometry of the drone and its application. So, let us begin with this lecture. So, if we look at the overall architecture diagram, so there is a UAV system and this UAV system requires certain peripherals. So, communication is there with the help of the base station. At the base station, we have a base station or the control station where we are controlling the movement of the UAV. Then the UAVs, they are actually carrying with them the GPS devices which are communicating with the space-based system, the satellite system, and then there is a ground real-time monitoring of systems are also there. So, there is a communication between all that, and that then can give me a real-time data directly from the UAV system. So, it is important to understand what are those different systems. So, if we look at the various components of the drone, so we have like either multi-rotor copter or the fixed wing kind of a copter, or and there the common thing is that we have a payload systems where we are mounting the sensor systems, different cameras and the sensor systems, the aircraft itself, and the gimbal system which can support all these sensor systems, etc. So, this is a common kind of a thing, but in fixed wing the gimbal system is not required. You can put it in the aircraft itself. But more on the payload sensors, we have different type of sensors are there, and UAV system is carrying more than one sensor. It depends upon our requirements. So, it may carry, for example, the photographic sensor along with the sensor which can detect the temperature, which can detect the noise level and things like that, pollution level. Now, there are three broad components. The aircraft system is there, the payloads are there which are mounted on the aircraft system, and the ground station where we have the remote control. We are controlling the movement of the drone as well as we are processing the data. A real time data processing is done at the ground receiving station. So, these are three broad components of a drone. Rotary drone I have shown in the previous diagram. This is showing the fixed wing kind of a drone. So, in the fixed wing drone you can see there is a very long wing is there. We have a left wing section and the right wing section also there, and then we have the hatch systems, we have the assembly. So, the components are slightly now different here. The aerodynamics is also different here in case of the fixed wing UAVs as compared to the rotary wing UAVs. So, this is a typical diagram of the quadcopter. Four wings are there. So, this is a typical layout which shows the various electrical and electronic components, how they are connected with each other, and then how they are communicating with the receiver. So, there is a power source which is a lithium polymer battery, LiPo, it is short form is LiPo battery. So, there is a everything is connected to derive the power from the LiPo battery, but there are certain drones nowadays available which can drive the power from the solar system also, and collecting the data and then transmitting the data to the ground receiving point and ground receiving station where the data on a computer can be viewed and can be further analyzed. So, this is a typical quadcopter layout is there. There are different electronics, there are different components, uh, and several students as a hobby have developed their own prototype system which can fly to a certain height and collect the data. So, these circuit diagram, they are available nowadays in the form of the book also or DIY, do it yourself. and students as a hobby, they have developed in many of the institution different types of the drones. Now, if we have to understand the aerodynamics part, this is very, very important. There are actually lift in the upward direction of the aircraft, then there is a weight which will act downward, and there is a thrust and there is a drag. So, thrust will be created because of the roll axis, because of the pitch axis, and the drag will be in the opposite direction, and it will be due to the wind pressure and the other thing. So, these are the four forces which are acting on the aircraft. So, one has to make a balance and move forward direction in order to collect the data. Stability is also very important when the data is collected. So, it should be aerodynamically stable so that you can get good quality data. You don't get the blurriness in the data product. So, if you see the quadcopter, it has a 4 rotary wing and the rotation is shown here. So, when it is moving actually or taking off, how these wings are rotating, that has been shown in this diagram. When it is taking off movement, then you can see there is a rear and the front wheel which are moving in the clockwise direction, but the left and the right side, they are moving in the anti-clockwise direction. So, two of the wings are moving in the clockwise direction and two of the wings are moving in the anti-clockwise direction, and this is controlled actually from the controller at the hand at the ground receiving station. So, it is important to understand that how the rotation of these 4 wings will take place so that it moves as per the desired direction. So, if it is the landing off, you want landing to take place, then in that case you will see that this will be a downward. So, all the arrows are shown downward here. So, you have to slow down the speed so that now it is landing off to them. Now, another case where you want either the forward motion or you want the backward motion of the aircraft, of the rotary wing. So, if you want the forward motion, then just the rear vane is moving in the clockwise direction. So, it will just move in the forward direction. But if you want to move this in the backward direction, then the front wing will actually move in the clockwise direction. So, one of these is moving actually in the clockwise direction is depends upon the you want it to be to go in the forward direction or the backward direction. So, this understanding the rotation of the motor is very, very important. There are 4 motors along with these 4 wings attached to the quadcopter. Now, if you want a right motion or the left motion, so this is important to understand. One is the lift up and down, another is the forward and the backward motion, and third is the left motion and the right motion, so that you can cover a very large area from one control station. So, for right motion and the left motion also, the arrows have been shown. So, front wing and the rear is moving actually in the clockwise direction, where the left and the right, they are moving in the anti-clockwise direction for the left motion and the right motion. So, controlling the rotation of these 4 wheels in a quadcopter, you can move the quadcopter anywhere in the space in order to collect the data. Now, if we look at the anatomy of quadcopter, there are several components which are shown, and each component is very, very important and playing its important role. They are communicating with each other. One component is providing the input to the other component so that the other component functions according to the given directions. So, if some component fails, then the quadcopter stops working and it starts malfunctioning. So, here right starting from the A where propellers are shown, then the B is the motor part which is shown, C is the electric electronic speed controller which is fitted. So arrows are showing where they are fitted into that. D is a flight controller systems. This one is the flight controller system, very important part of the entire UAV. Then there is a frame, airframe, on which everything is supported. Then after that is the battery pack, because it will drive the power from that battery pack. Then we have the camera gimbal system, because that will support the sensor system which it is carrying. Then we have the landing strata, so that it lands comfortably or smoothly onto the ground. Then we have the front indicator, which is the front side of the UAV system, that is indicated by a light. So there is a small light which is always illuminated, and this will give you the idea of that. Then there is a first person video camera. This is also important if we want to see what is covered by the drone at any given time. And then K is a receiver system. So these are the different components, anatomy of the quadcopter, and each one is playing very important role for data collection. So let us see one by one their importance and their roles. So whenever we are talking of the propeller systems, these are those wings which are moving with a very high speed. They are also known as the rotors, the propeller systems. So they are with the different configurations, so that they can create a thrust when they are moving with a very high speed. So these propellers are very important component of the quadcopter, which is actually vertically taking off. Then the motor systems. So these quadcopters, basically they are actually supported by a motor, and the role of this motor is to move these propellers. And we have the brushed kind of a motor system and the brushless kind of a motor systems are there. So two kind of motors are available. In modern, it is a brushless kind of. Then we have electronic speed controller. So this will control the speed of the and it requires the brushless motor, so that you can control the speed. So this is some kind of electronic device. So that is why this is called the electronic speed controller. The next component we have is the flight controller or the autopilot. Very important, because it is assisting the manual flights along with some autonomous functions. So some of the UAVs are working in the autonomous mode, and the autonomous modes are very useful, because now you can actually define the path of that, and it will move along with the defined path. The next part is the airframe here, and the role of this airframe is that everything, right from the payload to other component, they are all supported on the system. So this is basically a structure, like a structure of the building. This is like a structure on which the everything is supported. So here it is a chassis, it is a frame on which all the components are supported. So this airframe should be very steady, it should be very strong enough actually to take off that load, and it should not break during the jerk also. Then we have the battery pack, very important component nowadays in all those electronic based or automized equipment, because it will drive the power from the battery pack. So normally and popularly it is the lithium polymer battery, it is called lipo battery. So some are employing two sets of batteries together, some are actually housing the three sets of batteries together in the UAV system. Then the next component is the camera gimbal system, and camera gimbal system is basically a frame which can support the sensor system, which can support the camera. So you are going to mount either the multispectral camera or a thermal camera or a normal RGB camera. So you require some kind of a frame, so that the camera system fits into that frame, and it is not shaky, it is not vibrating while it is up in the air and taking the images of the ground. And also the angle is also very important, at what angle it has been mounted there. Then you have the landing struts, and landing struts is that it will allow the drone to rest onto the ground. So maybe you are beginning to start your work, so this everything will rest on this landing struts. It is like a tripod when you are mounting the instrument on the tripod, so your instrument is safe. So similarly, the UAV is safe, drone system is safe on this landing struts. Next component is the front indicator. As I told you, there is a illuminating light which you can see from the ground also when the drone is flying, and this is indicating, this light is indicating that this is the front side of the. So as I explained you the motion, front and back motion, left and right motion, so it is important we define which side is the front, because this is a similar kind of a, all the four wings are similar. So this light, front indicator light, LED light, will actually give us the idea that this is the front side of the quadcopter. Then next one is the first person video camera, and this is very important. The first person video camera, it will allow the images to be transmitted to the user. So if I am the user on the ground and the UAV is flying and taking the images, I like to see how much area at any given time it covers, or it is taking the images of the study area which is required, or it is going outside the study area. So you can actually view the coverage right from the ground itself. So that is why this is important. So this facility has to be procured while procuring the system. Then we have the receiver system. So it will translate all the user interactions for the flight controller. So this receiver is also very important to communicate the instructions of the users to the flight controller system. Now there are some inner electronics of the drone. So there is a, for example, microcontroller is there. So these inner electronics are also playing very important role, and this microcontroller is called the brain of the flight controller. So it will provide all the instructions to control your entire flight. So control the measurements from all its sensors and tell the motors what to do based on both the sensors and the inputs. And this is often connected to a ground station. There is a station on the ground through radio systems and a radio link. So this is a very important component, electronic component. Then there are IMU, inertial measuring unit, popularly known as IMU, and very much necessary for the autonomous flights, because it will now incorporate many other things like accelerometer, like gyroscope and compass system. So they will all actually maintain the proper orientation of the aircraft when it is moving, UAV system when it is moving up in the air. So you will get the proper orientation, you can maintain the proper orientation through this inertial measuring unit. Then GPS system, very important role, because it is providing us the locational data and the time information. All the information, whether it is a photogrammetric based UAV or whether it is a LiDAR based UAV system, you need to correlate your entire data set with the real coordinate system, so that now you can compare your measurements from that data with the real ground situation, or you can club this data, you can merge this data with the other data products which you have collected from the geomatics tools, and you are using everything in the GIS environment. So this georeferencing of the data is very important, and there the GPS system is playing important role to provide you the real time coordinates of the different points. Then under the inner electronic systems of the drone, we have the attitude and heading reference, which is popularly known as AHRS. So it informs where the aircraft is moving and what is the orientation of that. So you get all that information with the attitude and heading reference systems. So this is also very important to know the whereabouts of the aircraft or the drone systems. Then we have the transmitter systems. As the name itself is suggesting, it is transmitting the instruction to the receiver via radio waves. So, you have receiver systems and it is transmitting the information through the radio waves. So, very important component, and one should know that how to use this transmitter system when you are operating the drone. Then there are several camera systems which are used in the drones. So, these camera systems are also important for us to understand. We may have RGB camera systems, we may have multispectral, LiDAR systems are also there. So, there are different makes and different companies which have come up to give you these cameras which can work with the different specifications. When we are working with these cameras and mounting it, the main component, the main part is the weight, that how much is the weight of the camera system. The second is the what is the resolution of the camera system. So, both are now related to the cost as well. If you want higher resolution images from a camera system, you end up paying more money. Then we have the LiDAR systems. So, there are different LiDAR systems or LiDAR sensors are available which are specifically designed to work on UAVs. So, this is just one example of Velodyne Puck Light LiDAR sensor. On the left side, I can show the Canon or the Phantom built-in camera in the DJI. So, these are some of the sensor systems. Thermal sensor is shown on the left side. So, there is a very small handy kind of a camera which is called FLIR, and then there is a multispectral camera system. You can get the images in several parts of the electromagnetic spectrum. So, these sensors are used depending upon the type of application, depending upon our data requirement which we are collecting, we can mount these systems. Please remember that when you are mounting these platforms, you have to ensure whether the UAV system is able to carry that much of load up into the sky and take the images of the area. Now, there are actually air sampling sensors. So, in addition to the remote sensing based sensor, there are sensors which are air sampling sensor, there are temperature sensors, there are pollution monitoring sensors are there. So, different kind of sensors are nowadays commercially available which one can actually mount along with the remote sensing based sensor, and you can get the data. These sensors will also collect the data, like this air sampling sensor will collect the data about SOX or NOx data, and you can actually get things like what is the pollution level which is present in the atmosphere. Similarly, if you want pressure data, you want humidity data, you want the temperature data. So, all that information can be obtained by fitting those sensors in the system. So, the advantage of that is that all that data which is collected with the sensor also is georeferenced. So, also has a real world coordinate system attached to that. So, analysis becomes very simple and very easy. Now, the power requirement is the main issue when I am discussing that it has a LiPo battery. So, this the low endurance UAVs actually they are flying and coming back to the area, or their endurance time is not very high because of this reason, that they require a lot of power and the battery is consumed within 15 to 20 minutes. So, many micro drones they have less than 20 minutes of flying time because of the power requirement, and flight range is about 15 miles. So, if you want to collect more data for your area, then probably this is the bottleneck, that their power requirement is actually the bottleneck when you are collecting the data. So, this is important when you are buying the drone system. You have to ensure that how much time it will fly up in the sky along with the payload. So, when it is full with the load. So, practical requirement is that our endurance and the range must be improved. So, right now this is not that great range and great endurance. So, for uh, improving that, we require some kind of a battery which can last much longer. We need better algorithms, but also powerful onboard computing systems, so which can calculate real time data when it is collected at the same time when it is collected by the neuron. So, overall efficiency of the system, when we are using this particular system, the overall efficiency is important to us, and we are determining the overall efficiency of this drone system on the basis of the algorithm which is used, which we have not discussed here. Uh, uh, we have discussed the components, various components, the software system, and the computing platform plus the mechanical hardware. So, there are several components together, not only just the hardware plus the software systems, the processing systems, which is important to get the overall efficiency from these devices. Uh, Now, it is very important for successful mission completion that we have a very fast system for collecting the data and very fast system for analyzing the data in the real time. So, in order to do that, what is required? The first requirement is our more power, because more you automate the functions, more power it requires. So, for example, multiple function and sensors and UV payloads such as the vision and the radar system, along with we have, if we have the system which can detect the heat or biological sensor or the chemical sensors. So, we are using multifunctions in the UAV. So, it requires more and more power, and probably in less than 15 minutes the entire battery will be consumed. If we are using it for a target detection and monitoring system, again this is the application where more power is required. If we are using the drone for search and rescue operation, where it is continuously actually monitoring and moving along that. If we are using it for medical emergency purpose, if we are using for infrastructure monitoring, monitoring the infrastructure from deformation and the crack. So, these are some of the application which I have listed over here, where what you need is you need more and more power requirement. So, because all these applications are not only from the data collection point of view, but from the computational point of view, they are highly intensive tasks. They require a lot of computational facilities also are required, which should be much faster. So, normally presently what is done, the computational facilities are normally done in the offline mode. So, data is collected, and once the data is collected, the processing is done later on in the offline mode. But there is a need, when we are talking of the real time application, there is a need that we collect the data, and at the same time we process the data using the computationally efficient algorithms. So, what is the kind of output we are expecting? A lot of outputs are there. This is an example only here, that we can create orthophotos. So, if you remember the lecture on photogrammetry, we have the relief displacement present in the aerial photograph due to the height of the objects or height of the terrain. So, we can actually remove that kind of a relief displacement and create orthophotos, and use these orthophotos to create the map of the area, the topographical maps or the thematic maps of the area. So, you can create these orthophotographs from the UAV data, and also you can create digital surface model. In many studies, this digital surface model is important because it gives me the height of the different objects above the ground. So, normally earlier we were dealing with the contour map which is in the center. We were dealing with the three-dimensional with the help of the contour map only, where the contour will show me the elevation of the ground. But on the ground itself, there are many features with the different height. So, I will like to know, when I am creating a 3D model, I like to know what are those different objects with different heights, because there are certain planning projects which require that. If you are suppose planning the suitable site for the airport, then a high rise building should not be there within the certain region. So, there should not be any obstruction. there should be a clear visibility kind of a thing. So, this all you can derive from the digital surface model, which is important. You can create a 3D point cloud data also. So, the visualization based, all those applications which are based on the visualization of the terrain, then you require a 3D point cloud data where you can actually visualize the terrain not only from different angles, from the different height also. Then you can create a digital terrain model of the. So, you can visualize the whole of the terrain in the third dimension aspect. So, these are some of the output which you can derive from the UA. So, what we want is, we want very fast output or processing of the data, and particularly when you have lots of images. So, at present the very big problem when we are using the UAVs is that you have huge data, you have very large number of photographs. So, how to quickly stitch those photographs together, create a mosaic, georeference them together and carry out the analysis, because this is the first requirement when we are talking of the real time analysis from the UAV images. So, thank you very much. This is all about this lecture.